Thermodynamics Test Questions Set Number 1. Question 1. The energy of an isolated system. A is always decreasing. B is always constant. C is always increasing. D. None of the above.
Answer: is always constant. Explanation: the system in which both the mass as well as energy cannot be transferred between system and its surrounding is called as isolated system. As the energy can neither be transmitted nor be absorbed, the total energy of an isolated system is always constant.
Question 2. The term which can differentiate thermodynamics from other sciences is, fill in the blank. A. Pressure. B. Temperature. C. Mass. D. None of the above.
Answer: temperature. Explanation: temperature plays a very important role in thermodynamics as force does in static and velocity does in dynamics. Temperature is the term through which we can differentiate between hot and cold. When two bodies are brought in physical contact with each other and one body has more temperature than other, then here transfer takes place from hot body to cold one. After some time they attain a common temperature and then they are in a thermal equilibrium. These phenomena are very important in thermodynamics.
Question 3. The thermodynamic work done by the system on the surrounding is considered as, fill in the blank. A. Positive. B. Negative. C. Neutral. D. None of the above.
Answer: positive. Explanation: the mechanical work is done by a force when it acts upon the body moving in the direction of the force. In thermodynamics, work transfer occurs between system and surrounding. Work is said to be done by a system when the energy is transferred from the system and it is responsible for or counted as some external mechanical change. When work is done by a system, then it is taken as positive, and when work is done on the system by the surrounding, then it is taken as negative. The symbol W is used for work transfer.
Question 4. When the heat transfer into a system is more than the work transfer out of the system, then A. The internal energy of the system remains constant. B. The internal energy of the system decreases. C. The internal energy of the system increases. D. None of the above.
Answer: the internal energy of the system increases. Explanation: when a system undergoes cycle, then the algebraic sum of all energy transfer across the boundaries is zero. But when a system undergoes a change of state in which both heat transfer and work transfer are involved, the net energy transfer is stored and collected within the system. If Q is the amount of heat transferred to the system and W is the amount of work transferred from the system during the process, then the net energy Q, W is stored in the system. This energy is neither heat nor work, but it is called as internal energy. As the heat transfer is more than work transfer, then the internal energy E increases. Q, W equals E.
Question 5. Practically, heat and work are completely interchangeable forms of energy. A. True. B. False.
Answer: false. Explanation: according to the first law of thermodynamics, the energies are converted from one form to another form. For example, according to Joule, based on his experiments, energy supplied to a system in a form of heat can be completely converted into work. But this process is not possible, because we know that in thermodynamic process internal energy of a system also increases. Thus, heat transfer, internal energy increase, work transfer, the complete conversion of heat into work is not possible. Therefore heat and work are not completely interchangeable forms of energy.
Question 6. First law of thermodynamics provides A. A statement that energy balance occurs when a system undergoes the change of state or the process. B. A statement about whether the change of state or the process is at all feasible or not. C. Both A and B. D. None of the above.
Answer. A statement that energy balance occurs when a system undergoes the change of state or the process. Explanation. The first law of thermodynamics states that the energy balance occurs when a system undergoes the change of state or the process. It states that if energy is supplied to a system in a form of heat, which can be completely converted into work energy. But practically it is not possible, because internal energy of the system also increases in the process. Thus, first law of thermodynamics does not provide information on whether the change of state or the process is feasible or not.
Question 7. The thermodynamic cycle in which net heat is transferred to the system and a net work is transferred from the system is called as A. Refrigeration cycle. B. Heat engine cycle. C. Both A and B. D. None of the above.
Answer. Heat engine cycle. Explanation. Heat engine can be considered as gas confined in a piston cylinder arrangement. Consider the following heat engine. The heat Q1 is transferred to the system and work W1 is done by the system. Then system is taken to its initial position by applying work W2 on the piston and heat Q2 is rejected from the system. This is the heat engine cycle. In heat engine cycle, a net heat is transferred to the system and a net work is transferred from the system.
Question 8. Which of the following is not the heat engine cycle? A. Refrigerator. B. Steam power plant. C. Mass of gas confined in a cylinder and piston machine. D. None of the above.
Answer. Refrigerator. Explanation. In heat engine cycle, a net heat is transferred to the system and a net work is transferred from the system. In the system of mass of gas confined in a cylinder and piston machine, the heat is added to the system and work is done by the system on the piston and vice versa. In steam power plant initially the heat is added from the furnace to boiler, this steam passes through the turbine and work is done, then the steam is condensed to water in condenser and the heat is rejected from the system, and finally work is done on the system to pump the water back to the boiler. But refrigerator does not consist heat engine cycle, because in refrigerator, the work is done on the system and heat transfer takes place from the system.
Question 9. A thermal energy reservoir has A. A finite heat capacity. B. An infinite heat capacity. C. A finite mass. D. None of the above.
Answer. An infinite heat capacity. Explanation. A thermal energy reservoir has a capacity of absorbing or rejecting an unlimited amount of heat without considerable change in its temperature. These are the large bodies, in which the heat enters or leaves are very slow and very minute. Heat capacity is the product of mass of the body and specific heat of the body. As the thermal energy reservoirs are the large bodies, their heat capacity will be infinite.
Question 10. Two reversible adiabatic paths. A. Can intersect with each other. B. Cannot intersect with each other. C. May intersect or may not intersect. D. None of the above.
Answer: cannot intersect with each other.
Question 11. Which property of a system is constant in reversible adiabatic process? A. Pressure. B. Volume. C. Temperature. D. Entropy.
Answer: entropy.
Question 12. Thermodynamics is the study of A. Energy. B. Equilibrium. C. Entropy. D. None of the above.
Answer: none of the above.
Question 13. What is the cyclic integral of dq t for reversible process? A. Less than 0. B. 0. C. More than 0. D. None of the above.
Answer: 0.
Question 14. What is the cyclic integral of dq t for irreversible process? A. Less than 0. B. 0. C. More than 0. D. None of the above.
Answer: less than 0.
Question 15. Any reversible path may be substituted by a reversible zigzag path between the same end processes such that the heat transfer during this zigzag path is equal to the heat transfer during original path. What are the processes involved in the zigzag path? A. Reversible polytropic and isobaric process. B. Reversible polytropic and isothermal process. C. Reversible adiabatic and isothermal processes. D. None of the above.
Answer: reversible adiabatic and isothermal processes.
Question 16. When a system is taken from state A to state B through a reversible path 1 and again the system is taken to its initial state A from B through different reversible path 2, then what will be the effect on entropy? A. Entropy increases. B. Entropy decreases. C. Entropy remains constant. D. None of the above.
Answer: entropy remains constant.
Question 17. What is the exergy of a system? A. The minimum work that can be extracted from a system till it reaches thermodynamic equilibrium with its surroundings. B. The maximum work that can be extracted from a system till it reaches thermodynamic equilibrium with its surroundings. C. The maximum entropy that can be increased in a system till it reaches thermodynamic equilibrium with its surroundings. D. None of the above.
Answer: the maximum work that can be extracted from a system till it reaches thermodynamic equilibrium with its surroundings.
Question 18. What is the effect on quality of the energy when it is conserved? A. The quality of the energy increases while conserving its quantity. B. The quality of the energy decreases while conserving its quantity. C. The quality of the energy remains same while conserving its quantity. D. None of the above.
Answer: the quality of the energy decreases while conserving its quantity.
Question 19. Which analyses are required to make energy conversion or energy conveying system more efficient? A. First law or energy analysis. B. Second law or exergy analysis. C. Both A and B. D. None of the above.
Answer: both A and B.
Question 20. What is a pure substance? A. A homogeneous mixture of two substances of same composition. B. A substance with constant chemical composition throughout its mass. C. Both A and B. D. None of the above.
Answer: a substance with constant chemical composition throughout its mass.
Question 21. A pure substance exists in A. Solid phase. B. Liquid phase. C. Gaseous phase. D. All of the above.
Answer: all of the above.
Question 22. What is a mole of a substance? A. 1 mole has a mass numerically equal to half the molecular weight of the substance. B. 1 mole has a mass numerically equal to the molecular weight of the substance. C. 1 mole has a mass numerically equal to double the molecular weight of the substance. D. None of the above.
Answer: 1 mole has a mass numerically equal to the molecular weight of the substance.
Question 23. According to the Avogadro's law, what is the relation between volume of 1 kilogram moles of oxygen and volume of 1 kilogram moles of nitrogen at normal pressure and temperature? Mass of 1 kilogram moles of oxygen is 32 kilograms and mass of 1 kilogram moles of nitrogen is 28 kilograms. A. Volume of 1 kilogram moles of oxygen is greater than that of nitrogen. B. Volume of 1 kilogram moles of oxygen is less than that of nitrogen. C. Volume of 1 kilogram moles of oxygen is same as that of nitrogen. D. None of the above.
Answer: volume of 1 kilogram mole of oxygen is same as that of nitrogen.
Question 24. A single phase pure substance has following properties: P, V, T, S, U, H, F Helmholtz function and G Gibbs function. Any one in these properties may be expressed: A. As a function of the same property. B. As a function of any one other property. C. As a function of any two other properties. D. None of the above.
Answer: as a function of any two other properties.
Question 25. Joule-Kelvin effect can be carried out by A. Throttling process of gas. B. Joule-Thomson expansion of gas. C. Both A and B. D. None of the above.
Answer: both A and B.
Question 26. What will be the net change in internal energy of working fluid of power cycle over the complete cycle? A. Net change in internal energy of working fluid will be positive. B. Net change in internal energy of working fluid will be negative. C. No any net change in internal energy of working fluid. D. None of the above.
Answer: no any net change in internal energy of working fluid.
Question 27. What is the relation between net energy transferred to net mass of the working fluid as heat in the power cycle and net energy transfer as work from the working fluid in the same power cycle, if the cycle works ideally? A. Net energy transferred to net mass of the working fluid as heat in the power cycle is greater than net energy transfer as work from the working fluid in the same power cycle. B. Net energy transferred to net mass of the working fluid as heat in the power cycle is less than net energy transfer as work from the working fluid in the same power cycle. C. Net energy transferred to net mass of the working fluid as heat in the power cycle is equal to net energy transfer as work from the working fluid in the same power cycle. D. Cannot say.
Answer: net energy transferred to unit mass of the working fluid as heat in the power cycle is equal to net energy transfer as work from the working fluid in the same power cycle.
Question 28. Which processes do the Rankine cycle contain? A. 2 isothermal and 2 isochoric processes. B. 2 isentropic and 2 isobaric processes. C. 2 isentropic and 2 isothermal processes. D. 2 isothermal and 2 isobaric processes.
Answer: 2 isentropic and 2 isobaric processes.
Question 29. At ideal condition of vapor power cycle, reversible constant pressure heat rejection is carried out at A. Boiler, B. Turbine, C. Condenser, D. Feed pump.
Answer: condenser.
Question 30. Which ideal process is carried out at the turbine in vapor power cycle? A. Reversible adiabatic compression, B. Reversible adiabatic expansion, C. Reversible constant pressure heat addition, D. Reversible constant pressure heat rejection.
Answer: reversible adiabatic expansion.
Question 31. In the TS diagram of vapor power cycle, what is the condition of stem at the starting of turbine expansion? A. Wet with dryness fraction 0.8. B. Wet with dryness fraction 0.99. C. Dry saturated. D. Superheated.
Answer: dry saturated.
Question 32. The engines which are operating on gas power cycle are A. Cyclic, B. Non-cyclic, C. Either cyclic or non-cyclic, D. None of the above.
Answer: either cyclic or non-cyclic.
Question 33. Internal combustion engine is the example of A. cyclic heat engine. B. Non-cyclic heat engine. C. Both A and B. D. None of the above.
Answer: non-cyclic heat engine.
Question 34. The cycle, which consists of two reversible isotherms and two reversible isochors, is called as A. Rankine cycle. B. Carnot cycle. C. Stirling cycle. D. Ericsson cycle.
Answer: Stirling cycle.
Question 35. Two reversible isothermal processes and two reversible isobaric processes are carried out in A. Rankine cycle. B. Carnot cycle. C. Stirling cycle. D. Ericsson cycle.
Answer: Ericsson cycle.
Question 36. Which thermodynamic cycle, for the same condition, has highest efficiency among the others? A. Carnot cycle. B. Stirling cycle. C. Ericsson cycle. D. None. All of the above have same efficiency.
Answer: none. All of the above have same efficiency.
Question 37. What is the reason of the fact that the internal combustion engine does not complete thermodynamic cycle? A. Because every time fresh air is taken inside the engine and combustion products are thrown out of the engine. B. Because permanent chemical change is undergone by the working fluid in combustion chamber. C. Both A and B. D. None of the above.
Answer: both A and B.
Question 38. The heat pump. A. Receives heat from high temperature region and discharge it to low temperature region with production of useful work. B. Receives heat from low temperature region and discharge it to high temperature region with production of useful work. C. Receives heat from high temperature region and discharge it to low temperature region with utilization of external work. D. Receives heat from low temperature region and discharge it to high temperature region with utilization of external work.
Answer: receives heat from low temperature region and discharge it to high temperature region with utilization of external work.
Question 39. Where is main concentration in refrigeration for its calculation? A. High temperature reservoir. B. Low temperature reservoir. C. Both high temperature and low temperature reservoirs. D. None of the above.
Answer: low temperature reservoir.
Question 40. What is the effect of decrease in temperature difference between two reservoirs of heat pump on its COP? A. COP increases with decreases in temperature difference between two reservoirs. B. COP decreases with decreases in temperature difference between two reservoirs. C. COP does not affected by change in temperature difference between two reservoirs. D. Cannot say.
Answer. COP increases with decreases in temperature difference between two reservoirs.
Question 41. Dry air does not contain A. Krypton, B. Argon, C. Neon, D. None of the above.
Answer. None of the above.
Question 42. The ratio of partial pressure of water vapor in the mixture to the saturation pressure of water at the same temperature of the mixture is called as A. Humidity, B. Partial humidity, C. Specific humidity, D. Relative humidity.
Answer. Relative humidity.
Question 43. What is the specific humidity? A. The ratio of the mass of water vapor to the mass of the total mixture of air and water vapor. B. The ratio of the mass of dry air to the mass of the total mixture of air and water vapor. C. The ratio of the mass of dry air to the mass of water vapor in a mixture of air and water vapor. D. The ratio of the mass of water vapor to the mass of dry air in a mixture of air and water vapor.
Answer. The ratio of the mass of water vapor to the mass of dry air in a mixture of air and water vapor.
Question 44. The boiler in which the tubes are surrounded by hot gases is called as A. Fire tube boiler, B. Water tube boiler, C. Both A and B, D. None of the above.
Answer. Water tube boiler.
Thanks for watching. Please comment, like and share.